In this video, we are going to take a look at doing some angles and or rotations of trigonometric functions. So first of all, we have to remember that we have 4 quadrants, 1, 2, 3, and 4. And with that, in each quadrant, we can have specific angles, and we can calculate those angles or your rotations based on where it falls and the triangle that it makes. So for example, if in this first circle, let's say we had an angle that fell inside this first quadrant here. So we would have our angle. So we might call this our theta angle. Well, there's a few things that we need to pay attention to. First, this actually makes a right triangle. If you drop your vertical line all the way down to your axis, you can see that you would have x along the bottom. Your y would be the vertical piece. The actual angle here, this would be your radius. And that would make the point on the outer edge of your circle the point x comma y. And we can use all of those different pieces of information to calculate things like the distance of your angle. We can look for the x and y movement, and we can also make it in reference to your angle as well. Now we can do the same thing. So I've got 4 circles here, so we're just going to move around and look at how the coordinates change. So if we had an angle here in my second quadrant, again, this would be your angle. We would drop that vertical down to your x-axis. Okay, and so this again would be now a negative x. You would have y. This would still be your radius, and this point here now is going to be the point negative x, y. So the sign is very important to pay attention to as you work with your different angles. Now down in my third quadrant again, my angle goes between the angle to the x-axis. We would drop our vertical. Here we would have a negative x. We would also have a negative y. My radius still is the length of the blue line, and now in this case my point becomes negative x, negative y. Last but not least, we have your fourth quadrant. So drop in your angle. And then in this case, we're going to go ahead and you would drop your vertical line down. We're going to have a positive x, but we're going to have a negative y. We still have our radius, and in this case, our point becomes x negative y. So the quadrant you're in is really going to depend on the signs of your coordinate point. Now, why are these ideas important? Well, it's important because if we think about our trig function, not only would we have, say, the sine of your angle, but we could refer that in terms of your lengths. So the sine of my angle here would be the same as y over my radius. My cosine of the angle would be the same as x over your radius. And in terms of your tangent of the angle would be the same as y over x. So we can use that idea in order to help calculate our trig functions when we've been given distances instead of degrees or radians. Now we can use the idea of a reference angle to help us. So your reference angles are drawn again in the quadrant, but what we need to remember about reference is you always go up to your x-axis. Now with that, we can determine which angles are positive and which angles are negative. And we have a saying that helps us do that. And that saying is, all students take calculus. Now what's important about that is we use the A, S, T, and C from that saying in order to find out where or in which quadrant our different trig functions are positive and negative. So if we look at our quadrants here, okay, in this case we have, you would draw your C. So just like we know that this goes 1, 2, 3, 4, and if you look at it, it's like you're drawing the letter C. Well, we would do the same. All students take calculus. We're going to wrap that around our quadrants. So here we would have all students take calculus. Okay. Now, what exactly does that mean? Well, if we think about all, we are talking about all your trig functions. Okay, so this would be all of them are positive in this first quadrant. The S is going to stand for my sine functions. So this is going to be the sine and the cosecant are going to be positive in quadrant 2. T stands for tangent. So this is going to be your tangent and your cotangent. And then C is your cosine. So this is going to be cosine and the secants. Okay, so each of your trig functions has a place in which that they are positive. So if we're talking about our sine functions, your sine function is always positive in quadrant 2 and quadrant 1. That means it's negative in quadrants 3 and 4. Okay, and we do that with all of our trigs. Now the reason this is important is because some of the questions that we look at are just simply to determine if a terminal angle lies in a specific quadrant or follows a specific set of ideas. We can determine which trig functions are positive or negative based on the information given. Okay? So for example, we want to determine the quadrant in which the terminal side of the angle theta is located, and then state the signs of the other trig functions in the quadrants. So here we want that the cotangent is greater than 0 and the cosine is less than 0. So if we look specifically at what that means is that my cotangent of the angle is positive. Furthermore, that says that we are located in quadrants 1 and quadrants 3. Why? Because cotangent is a member of your tangent family, and it's positive in 3 and positive in 1. Okay. Now we want your cosine to be negative. So in this case, less than 0 says that your cosine of theta is negative. And in this case, what this means is that if the cosine is positive in 4 and 1, we are negative in 2 and 3. So in this case, we would say that this is located in quadrants 2 and quadrants 3. Okay. Now the question wants you to determine where exactly the terminal angle lies. So when we figure out our two directions, we are looking for which quadrant do they have in common. And in this case, we have quadrant 3 shows up for both of my directions here. So both the cotangent and the cosine. And so therefore your terminal sine is going to be in quadrant 3. Now after you identify that, it wants you to state the signs of the trig functions in the quadrant. Okay? So in this case, when we're in quadrant 3, we are down here. And so essentially what we would have is we would have that tangent of theta and cotangent of theta are positive. And then we would have that sine, cosecant, cosine, and secant are negative. So essentially what we're doing is we're doing a mini analysis of your quadrants and the angles that they have. Okay? So let's go ahead and look at it just one more time here. Now in this one, we have that the sine is going to be greater than 0. So we're looking at the sine of my angle being positive. And in this case, this means that we are going to be in quadrant 1. So we're in quadrant 1, and we are in quadrant 2. Okay, sine and cosine. Now the next one says we want the secant to be negative. Okay, so your secant of the angle is negative. So in this case, we have to look at where secant falls. So secant falls right here in 1 and 4. But this is where it's positive. We want where it's negative, so it's going to be negative in 2 and 3. So in this case, we are in quadrant 2, and we are in quadrant 3. So just like before, we want to know where we have the same. Okay, so where is the sine positive and the secant negative? Well, the only quadrant in common is going to be quadrant 2. So in this case, we have that your terminal side is in quadrant 2. So we have to look at what is quadrant 2. So quadrant 2 is going to be my sine and my cosecant. So in this case, we know that your sine of the angle and the cosecant of the angle are positive, which means your cosine, your secant, your tangent, and your cotangent are negative. Now another thing that we can do is we can actually find the trigonometric values, okay, given information. So here we're given that the terminal side of the angle is located on this graph, okay, and it's going through the order paired negative to 11, and we want to find the values. So if you look at this, you can see right here that we are in quadrant 2. Okay, so there's a few things that we know. We know quadrant 2, okay, and this is going to mean that the sine and the cosecant are positive. Your cosine, secant, tangent, and cotangent are negative. Okay. Now we also have our triangle. So if we look, we have our triangle that would come down this way and across, with this being beta. This is our radius, and then we were told that this is the point up here at negative 2, 11. So if we look at that, what that's actually saying is that we have negative 2 is our x value, 11 is the y value. Now in this case, we have a right triangle, and so we can use Pythagorean's theorem with the given information in order to find our r. So our radius squared is going to be negative 2 squared plus 11 squared. So in this case, we're going to end up with r being 5 square roots of 5. Okay. Once you have your full triangle, you have everything you need in order to find your results. So remember, when we are looking at the sine of your angle, your sine is going to be y over r, We don't know what the angle is, and that doesn't matter. All that matters is we can plug our information in. So when we're looking at that, our y is 11. So this would be 11 over 5 square roots of 5. And so in this case, we would end up having a reduced value of 11 square roots of 5 over 25. And we get that by rationalizing our denominator. So remember, take the radical, multiply top and bottom by it, and then reduce. Okay, so that's the first. Our next would be the cosine of beta, which is going to be x over r. So this is going to be negative 2 over 5 square root of 5. When we rationalize, becomes negative 2 square roots of 5 over 25. The next one we might look at would be your tangent. Tangent is going to be y over x, which in this case would be negative 11 over 2. So those are your majors. Now remember, the last three, or remaining three, are just simply the reciprocals. So in this case, we would have, instead of sine, we would have the cosecant of beta. The cosecant of beta is going to be r over y, which in this case would be 5 square roots of 5 over 11. My secant of beta is going to be r over x, which again is going to be 5 square roots of 5 over the negative 2. Okay. Now obviously the other way that you could simply write that would be negative 5 square roots of 5 over 2. Now last we have the cotangent of beta, which is going to be x over y, which in this case is going to be negative 2 over 11. Okay. So we found all 6 of our trig functions based on the triangle information that's been given. The most common example that we have for this is where you're asked to find the terminal side of an angle in standard position given a specific line and the quadrant you have to use. And then in this case, we would want you to find sine, cosine, and tangent. Okay? So we have the line 2x plus 3y equals 0. The first thing that I would do is I would rearrange into slope-intercept form. Okay, so I would rewrite into y equals mx plus b, because that's going to be one of the easiest ways for you to go ahead and graph your line. And so in this case, we would subtract 2x divided by 3, so we end up with y is equal to negative 2/3 x. Now the other thing, there's a few things that we know about this line that we can pull. First, we know our slope is going to be negative 2 over 3. Second, we know our intercept point is going to be the point 0, 0. Okay? Now the reason that helps us is because we need to do a rough graph, or we want to limit everything into quadrant 4, and we need to make sure that the line we have is going to do just that. So if we go ahead and create our coordinate plane, we would start with the point 0, 0, and then we're going to go down 2, 1, 2, and we're going to go over 3, 1, 2, 3. Thus 2 points to graph our line. So at this point, you could go ahead and draw it. So what we have here is we have our line, and the biggest thing that we care about is here in quadrant 4. Okay, so this right here is your quadrant 4. and we want to limit it to quadrant 4, hence kind of using a dashed line on the other half. So we need to set this up the same way we would, and I would go right from the one coordinate point that I know I'm going to have, which has to do with my slope. Okay? So in this case, my theta is going to be right here. My slope told me that my x value was 3, my y was a -2, and I have my radius. So that's going to give me the triangle that I want to use. Okay. Once you have that, we now have to find your radius. So remember, your radius squared is going to be -2 squared plus 3 squared. We'll then take the square root of everything we get, so my r ends up being the square root of that, -2 squared plus 3 squared, which in this case, my radius is going to be the square root of 13. Once we know that information, we just simply have to do what the directions asked, and they wanted you to find sine, cosine, and tangent. So remember, the sine of my angle is going to be y over r. So in this case, we're going to end up with -2 over the square root of 13. When you rationalize, we end up with -2 square roots of 13 over 13. My cosine is going to be x over r. My x in this case was 3 over the square root of 13. Again, rationalize gives you 3 square roots of 13 over 13. And the last one we have to do here is the tangent. Tangent is y over x, which in this case would be -2 over 3. Okay. Now that's all that you were asked for this particular problem, and so that's all that we would have to do. Now along those same lines, we can ask you to do the exact same problem, only in this case I'm giving you the sine function. Now there's some specific information I'm telling you about it. Here I am telling you that your sine of the theta is negative. So when we thought or looked at our all students take calculus, so if we take a look again here, remember my sine is positive here in quadrant 2, but it's going to be negative in quadrants 3 and 4. Okay, so I have two options for where sine is negative. So when I'm looking at a problem like this, I know that I will be in either quadrants 3 or quadrant 4, but at this point I'm not quite sure. Now what happens is we're then given our limited. So here we're told quadrant 3, so that's what's going to dictate where we are. Okay, so that is how you go about figuring out where your triangle has to be. So now if we draw it, I know I'm in quadrant 3, so I can focus myself on quadrant 3. I know that my angle would come down here. So I've got some information. Here is my theta. I need to drop in that vertical. And there's a few things that we know about it. We know that it's -5 over 13. Well, there's a few things we know about sine. We know sine is going to be opposite over hypotenuse. Okay? In this case, that means we are looking at y over r. So here we would have -5 over 13 with my x being the one that's missing. Again, you could use Pythagorean's theorem in order to find it. So in this case, my x is going to be the square root of my radius squared, so 13 squared minus the -5 squared. In this case, x is going to give you 12. Now, if you're really good with your Pythagorean theorem identities, you would see that this is actually a special triangle, kind of like the 3, 4, 5 triangle is, in that the partners would always be 5, 12, and 13. So if you're really good with your Pythagorean identities, you don't necessarily have to show Pythagorean's theorem, but this is the excellent way for you to be able to check that work. Now that we know all the sides, we could go ahead and find the exact answers to the other 5. So we wanted to know the cosine of your angle, which is going to be x over r. So in this case, it's going to be 12 over 13. Your tangent of the angle is going to be y over x, which in this case is negative 5 over 12. Then we have the cosecant of your angle is the opposite or the reciprocal of your sine. So this will be negative 13 over 5. We then have your secant, which is the reciprocal of cosine, so 13 over 12. And the cotangent of your angle, negative 12 over 5. So if you have any questions, please feel free to ask. Otherwise, this is everything you would need to know to get started with your quadrants. Okay? When in doubt, always remember that you want to come back to All Students Take Calculus. Remember, quadrant 1, all of your trig functions, all 6 of them are positive. In quadrant 2 is just your sines. In quadrant 3 is going to be your tangents. In quadrant 4 is going to be your cosines. So what that means is anywhere that your trig functions are not positive, they are negative. So as long as you always refer back to your All Students Take Calculus quadrants, you should always be able to identify the sign of your trig functions. So I hope you enjoyed this video. If you have any examples that you need extra help with, please be sure to send those off to me. Otherwise, I look forward to seeing you next time.